Welcome to the session number 33 on operating system and Linux. I'm Manibhushan D'Souza, and in today's class we are going to look at file management. In particular, we are going to look at the file concept, the file attributes, file types, and the access methods. We are all familiar. One of the most visible part in the operating system is its file system. So the first thing that we do in operating system is try to access the files. The files could be the program files that are your applications like your Word, Excel, PowerPoint, and so on, or the other data files that you have stored, like the Word document that you have stored or the Excel spreadsheet that you have stored. So most of the time when we look at the operating system, the one thing that is most visible to us is its file system. So what does this file system do? The file system provides a mechanism in which we can store the data or our program into the secondary storage device and then access it whenever we want to access them. So when you look at the file system, it consists of two distinct things that you are all familiar with. One is a set of files that you are storing it, which may be a data or which may be a program or something that you want to store it. And the next one is the arrangement in which you store them. That is, you organize the content and store it. How do you organize these files? The files are organized in the directory. In Windows, we usually call them as folders. So we arrange them in a neat way so that there is no clutter in the file system. Just imagine if you have all the files at one place, it will be very difficult for you to search for the required file. So we arrange them neatly using the directory. Now, most of the operating system have one other part, and that is the partition. So given storage device is logically divided, or sometimes we physically divide them so that the arrangement is more smooth. For example, on your laptop you have C drive, D drive, and so on, but there is only one hard disk, one secondary storage device, but it is logically partitioned into different drives. So this is one other way of arranging the files. Okay. So when we look at the computers, so computer can be connected to many storage devices. You know very well, a computer can store information in a magnetic medium like your disk, or it can store the information in the optical medium like your CD or DVD, or it can also tunnel and store it. These are your pen drives and other, which is actually an electronic way of storing the content. So there can be many different ways in which the information can be stored. However, the way in which the contents are stored on a magnetic medium or an optical media or in a tunneling, they are all, the technique that is used is very different, and these techniques are very complicated. However, what the operating system will do is it will abstract out all the physical properties, all the physical details from the user, and it just provides a logical view of the content. And generally, it is shown in the form of a unit, that is the files. Okay, somehow the operating system will map this data or your file, that is a unit that you are want to store it, into the physical media, and it allows you to retrieve them at later time. So they, when you store the data in the secondary storage device, you know very well they are persistent so that they can be retrieved later. Okay. Now, what is a file as such? So we need to know about that. Okay. File is nothing but it's a named collection of related information that is stored on a secondary storage. So it's a named collection of related information. What is the meaning of that is you have set of related information, maybe names of students who are studying in one class, or the marks obtained by a particular student, or maybe the attendance of all the students or the salary of all the employees. They are all related information that you want to store it. However, you don't clutter them by putting at different places. You store them as a single unit and you give a name for that collection. So all the employees, that information that you store inside your secondary storage device is given a name like employee details or employee files or salary files or attendance files. So somehow you give a name to this collection, and that is what is the meaning of saying named collection of related information. Okay, from the point of view of the user, so who is using the operating system, a file is the smallest allotment of logical secondary storage. What is the meaning of that is, it's like you have studied something in your primary called as an atom. Atom is the last unit most thing. Similarly, when we talk about the storage, for us, file is the storage unit. There is nothing smaller than the file. So if you divide a file, you get two files. You don't get half files. So there will, a file is the last unit. So the smallest allotment that you get inside a disk is the, or inside any secondary storage device, is the file. Okay. And the other part you must understand is you cannot store the data anywhere and everywhere you place it. You have to store the data inside a file. Somehow there must be a logical unit called as a file, which is given as some name, and you're going to access them. Okay. So commonly when we look at a file can be, for us, for a computer science students, file can be even program files that you have written, or maybe the compiled file, or maybe the data file that you have. So the data could be the numerical data, the character data, alphanumerical data, and so on and so forth. Okay, when we look at the file could be very have a free form. That means you can write the file like if you are writing a text document, you can write anything, any length of sentence, and then press enter, it will go to the next line. So it is stored line by line. So there is no rigid format. But if you are trying to store the details of an employee inside a database or inside some storage device, then there is usually a proper structure in which you have to store it. For example, you are supposed to store the student register number first, and it may have a capacity like it must be 10 characters. Then you are given 50 characters to store the name of the student, then maybe a 5 character to store the class or the course that the student has taken. So there is a rigid format in which the information has to be stored. So either you can have a free form wherein you know very well, whenever you store write a file or a text document, you know the length of this text document can vary. Some lines can be shorter, some lines can be longer, and so on and so forth. So there is no rigid format in which the content has to be stored, whereas when it comes to the file with formatted or a rigid content like your database kind of file or a record, when you are trying to store a record, there is a rigid format in which the file has to be stored. So in general, we can say that file is nothing but it's a sequence of bits, bytes, or lines or records. It could be anything. So because if you are just taking your image for that, the image is stored in the form of bytes. Whenever you store your photos into the machine, they're stored in the form of bytes, and you know very well your text is usually stored in the form of lines. And the database content that about your student attendance and so on, so they are usually stored in the form of records. So it's in general a file is a sequence of bits, bytes, or lines or records, meaning of which is defined by the creator. So what is the meaning of this is, what do I mean by saying that? Meaning of it is defined by the file's creator or the user. It means the content of the file is not important to the operating system. So operating system will not try to interpret that file. So how you have stored the data, how you have written the program, which program you have written, that makes sense to you, not to the operating system. For the operating system, it is just the file. For it, it is just a file that you are storing. It may be a bits that you are storing, or bytes that you are storing, or lines that you are storing. That's it. It knows only that. Set of lines are stored, set of bytes are stored, set of bits are stored. That's it. I know only that. Whether it is an image, whether it is a video, whether it's a audio, whether it's a text, it makes sense to the user who created it. It will not make sense, or it make sense to an application that created it. Suppose when you are storing the file from the Microsoft Word document, then the Word document, that application knows the format. Operating system doesn't bother about whether you have stored a Word document or Excel or PowerPoint or anything. For it, it is just a file. It's a information that you have asked it to store in the secondary storage device. That's it. It will not try to interpret the meaning of it. So meaning of the file, or the meaning of the information that is stored in the file, makes sense to the user who is using it. Now the user could be like me and you, humans, or the other application that is making use of it, but it does not make any sense to the operating system, because for it, it is just a piece of information, or a piece of bit, byte, or lines. Okay. Now let's look at the other part. So whenever we say a file, so a file has a predefined structure. Most of them have. For example, text file, whenever you say, it's a sequence of characters that are written in lines. If you have a source file like C or C program, there is a subroutines. Subroutines is nothing but your functions, in C programs. So you write the C program in the form of a function. So your file is written in the form of a function, and some declaration may be there. Yeah, if you take the after compilation, if you get the object file, it's a sequence of bytes. Okay, the blocks are arranged in such a way that the linker is able to interpret them. And the last one is the executable file. If you have the, okay, it's a series of code section. The loader knows how to read it and how to place them into the memory. Again, operating system does not make sense, but there is a structure in which the files are generally stored. When we say that operating system, it doesn't make any sense to the operating system, does not mean that there is no structure. The structure is defined by somebody else, and every files will have their own structure. Now when we look at a file, we know that a file is named so that we can easily retry the files, and that is what you know very well. Whenever you try to save a file, the operating system will ask for the name of the file, and later if you want to open that file, you can specify the name of the file, and the operating system will do the needful thing to you. Is it only that information that is stored with it? Okay, so there may be other information that is also stored with it. They are called as the attribute of the file. Okay, so when we look at the name of the file, okay, so name of the file is nothing but it's a string of character. Now the characters could be alphanumerical also. Some operating system allow or most of the operating system allow some special characters to be used, but not all the special characters. So some of the special characters are reserved, like the greater than symbol or less than symbol or pipe symbol. They have their own meaning. We cannot use, or the slashes cannot be used because they have the other meaning. But most of the characters can be used, and in today's world you can store the files not just in English, you can store it in the other regional language like Kannada, Hindi, Marathi, or any other language that you prefer to use it. So it's just a name is just for your reference that you are using. However, like Linux, there is a, if you are using English, there is a difference in storing it in capitals and small case, because Linux was written using C programming language, and you know very well C distinguishes between the uppercase and lowercase. So what you write in uppercase is a very different file, and if you try to search the file using the lowercase, it will not give you the result because it distinguishes, whereas Windows or DOS may not make that kind of a distinction. Okay, when we say that when we give a name to the file, you give the name to identify that file. Okay, Now, the name has nothing to do with the processes that uses it. So, I can create a Word document and give a name to that file as my resume or my CV. So the file name becomes a .cv. Now that file can be used for emailing to my friend or to the company, or taking the printout and so on and so forth. So which process uses that file does not bother about the name of the file. Okay, so the name, it is not like, if you are using Word document, you have to give this name. If Mr. X is using the file name, he has to give this name. It's not like that. It's independent. You can independent of the user or independent of the application, you can give any name. So you are familiar with that, so there is no restriction as such. Okay, now, as I've already told you, one of the visible attribute that you see in a file is its name. So everybody looks at it. So name is used to identify the file, so that it is easier for a human to identify them. Okay, so apart from the this attribute, a file will have many other attributes. The other attributes includes the identifier of the file. So identifier is a number that is usually stored by the file system, like inode we use in Linux. So this is used by the system, but it is not used by humans. So it may not be in the human readable form. It's like your register number. I know the most of your names, but I may not know any of your register number. So register number also identifies you, but for my convenience I refer you using your names. So name is easier to identify, okay, remember and identify. That's why names are used. However, internally the operating system uses an identifier. The next one is the type of the file. So this is used to distinguish one type of file from the other type of file. Like if you have a multimedia file, like a movie file or audio file or image, or you may have text file, or you may have numerical data and so on. To distinguish one file from the other, we have the type of the files. The next one is the location. This is also part of the file, where that particular file is being stored. So on which device a particular file is being stored. So that is nothing but the location. The other one is the size. How much, what is the amount of disk, or what is the amount of storage that particular file takes. Now the size can be in terms of bytes, this is the general way, or it could be in terms of words, or in terms of blocks. Okay, there are chances that some of the system may even say what is the maximum size that a file can have. So that is also an attribute. Next one is the protection. Protection is the access control. Who can access it? Okay, and what type of operation they can perform it. So like can they read, can they write, can they modify, can they uh, execute a particular program. All these are nothing but protection. Next one is when this particular file is created, the date and time at which the file is created, date and file at which the file was last modified, the date and time at which the file was last accessed. All these informations are there for security reasons, so that we know that who has accessed them. So user identification, that is a part of it. Okay, so all these information regarding the attributes of the file are stored in a directory. Now I told you directory is used to arrange the files in an organized way, so that we can easily access them. So the file itself will not store this information. The name of the file, its location, and so on and so forth, all these informations are there on a separate thing, and that is called as a directory. Okay. Now we know that a file is an abstract data type, and when we use the file, we may want to interact with the file, we may want to access that file. So the operating system must provide some system calls, either to create, either to manipulate, or either to delete the file. So let's look at some of the system calls that are provided by the operating system. First one is creating files. Now, whenever we want to create a file, we have to remember two things. First of all, we must get the place on the storage device. So if at all, if I want to store something on my disk, so I must get some space where my files can be stored. Okay, so first I have to get the space where that file can be stored. Okay, so if I find that information, next one I have to go to the directory and make an entry regarding that file. So two things has to be there. So first I must get, suppose if I have to store 50 MB of data into the file, in the secondary storage device I have to get 50 MB free space. Then if I get it, I can store that file on the disk, and then I have to come back to the directory and make an entry for the file saying that such a such file is located in this place. This is the name of the file. These are the attributes of the file. So that information, directory information, has to be stored. The next one is the writing into a file. Now, once you create a file, you can write onto the file. So how can I write onto the file? In order for me to write onto the file, I have to tell the operating system which file I want to use. That is, I need to specify the file name on which I want to store my content, and I have to specify how much, what is the information that I want to be stored. So I have to provide two things. One is the name as well as the information that needs to be stored. So what the operating system will do is, when I give the name, operating system will search for the name. Again, I may have to even give the directory in which this particular name exists. So operating system will search the directory structure for the given file, and it gets the location on the physical media where the file is being written to, or where the file is been stored, and then the operating system will keep a pointer that indicates where is the last place. If I'm updating and adding at the end, it will make a point into the file, the last place where, or the ending point of the file. At that point it will start adding the new content, and again it will update the pointer. In other words, if I have a file like this, there will be an internal pointer that says this is the end of the file. So if I add additional thing, the additional things will be added from this location, and this pointer will move and say that this is the end. So it's like a end marker. It will always mark where is the end of the file. Now again, a reading idea is also same. Excuse me. So whenever we want to read that file, we specify the name of the file as well as we specify which is the next block that has to be read. So from the current pointer, I have to specify how many blocks, or which is the block that need to be read. So once the content are being read, so like if you have a file here, initially the pointer will be pointing to the first location in the file. As you start reading, the pointer will start moving further and further, so that we know up to which point you have read in the file. Now this particular pointer is called as a current file position. Okay, so current file position pointer. So in your C program, you know very well, you have used FP, file pointer, whenever you use the just recall, you said FP, let me put it in small case, FP is equal to, yes sir, file open, F open, you might have used the function F open, and so on and so forth. You have written so many things. So that is the pointer that says, or F seek you might have used for seeking, moving the pointer to one location to the other. So this is how you can use it. So fseek is nothing but repositioning. Remember, reading means you are copying the content. So what's the difference between reading and seeking? So when you say reading, you read the content and place it into the memory. So this is an input output operation. This is actually input operation, not output. Whereas seeking is within the file, you just move the file pointer. From here you move the file pointer to the other place, you don't read the content, you don't transfer anything back to the memory. So that is called as a repositioning. Okay, how do you reposition it? Again, you have to tell the name of the file, and the operating system will search for the name of the file in the directory structure, and it will go to the place where the file has been stored and it will move the file access pointer or a file pointer to the corresponding place whichever you have specified. Next one is the deleting of the file. So suppose if you don't want that file, you can delete it from the storage device. So once you delete this particular file, what happens is that much of area is freed, and some other content can be stored there. So you can erase the content. So when you delete the file, what are the things that will happen? First one, operating system will search the directory for the file. It will go to the secondary storage device and erases the space that is being used up by the file, and it will come back to the directory. You know very well, all the attributes of the file including its location are stored in the directory. So once the physical file has been erased, it will come back to the directory and erase the directory entry for the file, so that the file will not be visible to the user. Next one is a truncating. Sometimes we want to reduce the file size to 0. So we don't want to delete the file. Remember, when I delete the file, all the attributes are gone. What we mean by saying that is, when you delete it, the directory entry will be deleted. When I delete the directory entry, I will lose all the information, when the file was created, when it was modified, and so on and so forth. So I lose all the information. Sometimes we may not like to lose all the information, but we want to reinitialize the file, delete all the content and put a fresh content. For that we use the truncate. So truncate means it erases the content but keep all the attributes. It will not. So what is the meaning of it is, during the truncation, the operating system will go to the secondary storage device. It will erase all the content and make the size of the file as 0, but it will not erase the, or it will not delete the directory entry. Okay. The other type of operation that you can perform on the file could be appending the new information. What is append? Append is add at the end. So if you have a file over here, you can add additional information at the end. This is called as appending, adding at the end. Then you can copy one file to the other file or to the other device as such, and also get the attributes, like when that file was created, who created that file, what is the permission that the file has. You can either get the file attribute, or set the file attribute. You can put the new information back. Okay. Now, as I've already told you that there are different types of files are available. Suppose if the operating system has to recognize a particular type of file, then you must do something. So why the operating system, the next question that comes is, why the operating system has to recognize a file? You may say that just now you told me that when you create a file, the meaning of it makes sense only to the user. Now now you are contradicting whatever you said earlier. Now you say that operating system may want to recognize a file. What is the reason? Now, why the operating system want to recognize the file is not because it want to interpret the data inside it. Remember the content that you have added. If you say I am going to create a file containing list of my friends, your friends details, Mahesh, Dinesh, Suresh, whoever are there, that detail operating system is not interested. So the content the operating system is not really interested in, but it may want to associate that file to some other application. So when you know very well, when you double click on a PDF file, either Acrobat Reader or some other reader will open up, or Foxit or anything, depending upon which reader that you have, automatically opens it. If you double click on a Word document, Microsoft Word will open. So how does the Microsoft Word knows, how does that thing happen is, the operating system realized that this is a Microsoft Word document and it associated that with the Microsoft Word application. So when you double click on it, it combined them together. So in other words, the operating system may want to use the type of file information so that it can operate on that file in a reasonable way. Now, I don't want to say that that operating system will try to interpret whether the salary of one employee is greater than the salary of the employee is less. That kind of interpretation it will not do, but it will try to recognize that, okay, this is a database file. So in other words, what are the different types of files, so that it can take some specific action. Okay, how can I make the operating system recognize a particular file is, either I can put that information inside the file or in generally we put that information as a part of the name. So when we type the name of the file, we add some extra information with the name so that the operating system can read that information and then recognize that file. Okay, so generally whenever we write a name of the file, we divide the name of the file into two sections. First we give the name, whatever the name that we please, we give the name. Then we put a dot. After that we put some other characters. Okay, so these are called as extension. This is the file name and it is an extension. So the operating system will look at this extension and then try to interpret the type of the file. So usually this extension is separated by a physical period so that the operating system knows what type of file it is. If you have used the MS-DOS, the very old operating system, MS Office has there was a restriction on the size of the file name, so it can have only 8 characters. File name can be only 8 characters, followed by a dot and followed by 3-letter extension. So for example, you can have .doc, which you are all familiar. Okay, doc is a document, Microsoft Word document, or BMP, or at least a JPG. Most of you have seen this extension, JPG or PNG. Now all these are the 3 letters extension that is used by the operating system to recognize the type of the file. Now when the operating system recognizes the type of the file, it can then say which application can use it or what type of operation can be performed on it. For example, in the DOS operating system, that is MS-DOS operating system, excuse me, if the file size is .com or .exe or .bat, then for MS-DOS, these extensions indicate that the file can be executed. Remember, in the Unix, that extension does not make any sense to it. If you want a file to be executed, it must have an execute permission. In the DOS, that is not really required. Now these are some of the common file types that you see. The executable usually generally referred as a .exe or bin in most of our Linux system. They are recognized as bin, that is binary. Then you have object file obj or .o. Then the source file like CC, Java, and so on and so forth. Then you may have bash file .bt or .sh, shell script. We are going to look at that shell script in the lab. You may have text document and so on and so forth. So you have a different extension for many things, like you have MPEG. So one of the things that you are familiar with the MPEG coding is MP3, layer 3 encoding, MP3 format, or MP4 or .mov. So these are all zip files for archival. So these are all the different types of files. When you talk about Unix file system, I already told you, Unix actually stores something called as a magic number inside the file. So inside the file only it stores some information called as a magic number at a particular location. That indicates what is the type of the file. Okay. Now when we look at the type of the file can also be used to dictate the internal structure that a file must have. For example, when we say executable file, in most of the operating system, executable file must have a particular structure. So sometimes when you try to, for example, if you copy a exe file from your Windows and try to copy it onto a Unix system will not execute that. The reason is, or if you take a 32-bit, I don't know whether you are familiar with the 32-bit and 64-bit processor. If you take a file that was compiled for a 64-bit operating system and then try to open it on a 32-bit, the file will not open, even if it is done on a Windows system itself. So Windows 64-bit program compiled for 64-bit, you take it to Windows 32-bit, the operating system says that I can't recognize the content of the file. It's not proper because the things are not there at a proper position. Okay, so when you say the file structure, so there must be a proper structure so that operating system knows that this is an executable file, and the loader must know which part has to be loaded, how it has to be loaded, and where is the beginning of the instruction. All these informations are required. So in order for the loader to recognize how to read the content and recognize which is the starting instruction, there must be a structure for the file. So sometime the operating system, in particular for the executable file, there must be a way in which the file has to be stored. If you store it in a different way, it will not work. Now we know that the file is stored and the operating system is reading the content for us. So whenever I tell the operating system read something for me or write something for me, the operating system is going to do that. But the next question that comes to us is, how does the operating system reads or writes to the disk? In other words, we need to know the access method. How does the operating system accesses the file? So there are many ways in which the file can be accessed. Okay, one of the simplest way is the sequential access. So in the sequential access of what is being done, now again I am not very sure whether your generation has seen a cassette tape. So I don't whether you've seen it or not. If you've not seen it, I can't help it. So this cassette tape, there was a reel here and there was a reel here and there was a tape that was taken from here and it used to come to the other. You may have, if you are fortunate enough, if your dad has not thrown it out or given it to Radhiwala, you will find a cassette tape. Okay, now if you just look at this part, the top part, okay, if you see it in the three-dimensional world, so I'm going to use this one and redraw it. So if you look at this one, it's a continuous tape. Again, I don't know whether you have seen your photo reels. Now even that thing is not there, so you don't have films, photo films at least. Now olden days we had that film also. Whenever we take a smile please, we used to click it on a Kodak film, but it is not there today. So even that's difficult, but anyhow you got it. So you have a file continuously. So what happens is you have the file access reader. So you can read one thing at a time. So that is it. So you read this one, then go to the next one. Oops. Then go to the next one, then go to the next one, then go to the next one. So you have to do it in order. Again, if you go to the end of the, I don't know whether anyhow, today you don't make much of a difference to us. When we were kids, when we wanted to play our favorite song, and what happens in the cassette, so this was a cassette and we had this cassette reel here. So it used to start from here and go to the other side. So once one song is over, now today if you want to play the song again, and your repeater option is there on your Android, but or you can again double click on the file name, it does it. Today everything is very fantastic. In when I was a kid, if I want to play back the same song, then I have to rewind it. So the tape will go rewind it very fast, it will rewind it back and then again start playing it. Okay, so it is in the order. So from, if you are there in the first record, you have to go to the second. So if you are there in the first song, you have to go to the second song, then third song, then fourth song, and in the order. If you want to come back from fourth, you can come to third, then third to second, and second to first. So there was an order in which it is used. So this particular model is based on the tape model. Okay, and the access was sequential. You know what is the meaning of sequential? One after the other. So information in the file is processed in the order, one record at a time. So you read the first song, instead of song you can take it as a record. You read the first record, then go to the second record, then go to the third record, and so on. This is the most common way of accessing it. So this is generally is been done by most of the editors. Like when you start writing a program using your favorite editor, like the one vi, you can use it now, or you might have used the notepad plus plus or any other editor. I am not here to advertise the companies, but you have used them. So what happens is you read it, so the file pointer will point to some location. Okay, you may write it. So again the file pointer has to be moved either forward or backward direction, or you can reset it to start from the beginning. So this is how the sequential access will work. Suppose you are if your current position is here, you can read it or write it in the forward direction. Again you can rewind the pointer to the backward direction. You cannot directly jump here. So today on your phone you can directly jump from one song to the other. You can do any wonderful things. You can edit a video and so on and so forth. Things have changed, but in olden days the things were not like that. From one you can go to the second, from second you can go to the third you can go, and so on and so forth. That's a sequential access. The next one is the direct access. So the direct access is also called as a relative access. Now here the records are made in the form of blocks. Okay, there is a fixed logical record. Okay, you can read it and write it rapidly. Now I am going to whether again this is even more difficult for you to understand. In olden days there was something called as LP records. Okay, the old, you might have seen the record player. So this record, there was this pointer was there. There was a pointer which can point, and this used to rotate. Okay, either here or this, and there was a pointer. At least you have seen this hard disk. Okay, thank God you have seen studied the structure of this hard disk. So in the hard disk, what you have here is you have not this square. Hard disk is not square. So what you have here is in hard disk you have tracks and sectors. You have studied that. Now don't tell me that you didn't study this one. Now you have tracks and sectors. So what if you are here, if you are in this sector, you can shift to the other sector, because that pointer, you know, that pointer can be here. It can immediately shift to the other. It can skip all these and then directly shift to the other. Look at the tape. If you are here, then you have to read all of them and reach here. Whereas if you are in this location, instead of reading this whole thing, you can simply jump to the other track. This is the direct access. So from your device, you know very well, you can be read it here. Remember, it is in the tracks. Okay, they are in the tracks. Instead of going in the track, you can simply jump to the other track immediately. So that's called as a direct access. You can skip from one place to the other. So there is no particular order. You can go forward, backward, or any other direction you can use. So this is generally based on the disk model that you have. Okay, so here what we see is we see the file in the form of a blocks, and we can arbitrarily go between one block to the other. So in other words, you can go from the first song to the third song. It was possible in old gramophone records. It was possible. Now then you may say that why did that gramophone records didn't survive? There is a reason for that. Okay, the clarity was not there, and there was no 2-channel and so on and so forth. There was many problems with the gramophone, but then that was mechanical device. And why cassette player didn't survive today, why you have the MP3 players and other thing, is cassette used to get stuck. Okay, so whether you know it or not, cassette used to get stuck and it used to break, and sometimes it used to get very tight and fungus used to go there, and a lot of problems. Okay, we faced that. Thank God you are not facing it. Okay, so they didn't survive. So today you have the random access, directly you can get that thing. Okay, so let's come back to the direct access. For direct access method, file, whenever you want to read it, you have to specify two things. You can't just say read. For the sequential access, you have to just say read. Why you have to just say read is, when you have the tape, if the pointer is here, reading is you can only go in one direction, and that too in a order. Whereas when it is in the desk, you can jump from any place to any place. Okay, so you have to specify which block you want to read. So it's not enough you just say read, you have to even say read the nth block. Okay, so what is this nth block? You may rename, you may give the name like this. The first block may have, so you may have like this, you may have, this is the 0th block, this is the first block, second block, and so on. You can directly jump from one block to the other block. There are other type of access methods which are there, which are usually based on top of the direct access method. So one of them is the way in which you can access is using the index. Now when you have the books, you know very well, at the end of the book you have the indexes. Why do you use the indexes? Quickly access the page. So the keywords will be there and a page number will be there. You can quickly go to the, if at all you search on the keyboard, I mean a keyword, you can quickly go to that particular page. In the same idea was used here also. Here also we use index file. The reason why we use index file is, if the file is very large, it is very difficult to go from one place to the other. In that case, what is being done is we maintain a index. So this is how you have it. So the names will be there. For example, in the dictionary order, the name followed by where that file is located. So this is the index. If the index says it is in the 50th record, you come here, search along the index. Okay, I want to go for the Smith, it is in the 50th block, go there and read it. So index will contain the pointer or the location in the physical device where that content exists. Okay, so you just read the index to find out, quickly find out where that block exists on the storage device. You go and access that. So this is how you can use it. So this is generally used in the larger file, wherein you can have the indexes. Again, that idea can be extended. Now if you are studying the, you are not studying actually the Unix internal file structure, so there will be index blocks. Okay, it stores, you don't study this inode and all those things, in that it is there. So what you have is that there will be levels of indices. So this is the first level of indexes, then you have the second level of index, then you have the third level of index, like that, and finally you get it. You can have many levels. Okay, so first level will point to which file it is there. So like, again, hope everybody has gone to the library. So when you want to search, now again today you don't have that catalog also, everything is electronized, electronic. You can go and ask the operator there, they will search the book for you. In olden days there was a catalog. So first you search the catalog, then the catalog will say on which rack that book exists. Go to that book, get that book, search its index and go to that page. So this we used to do like that. First we have to search the catalog, library catalog. Okay, and then from the library catalog, it is going to give us the shelf where that book exists. We go to that shelf and then go to that particular rack and then get the book and open that book to find the indexes, and from the index we go to the page where that content was there. So this is how we used to do it. Now today the things have changed. You have the electronic version, the PDF version of the books, so you can directly search. That's all for today. If you are more interested in knowing the file system structure, please refer the Galvin's book. Thank you for your interest. We'll meet again in the next class.